Hello everybody. So we are back again with a lecture series on vector algebra. Now in the last few sessions we have talked about what is a scalar, what is a vector, the essential differences between scalar and a vector, and then the representation of vector in 2 and 3 dimensional space, as well as some other basic concepts and special type of vectors. Now today's class we are actually starting with the algebra of vectors, or rather various algebraic operations on vectors. And the first one to start with is of course vector addition. Now there are two very important or famous laws which govern this vector addition. They are the triangle law and the parallelogram law. In fact, the triangle law is the first basic law. The parallelogram law is again based on the triangle law of vector addition. So we start with the addition of vectors with the triangle law. And now first let us look into this picture. Now see that here we have a vector AB. Now essentially a vector AB means it is giving us a displacement from the point A to the point B. Similarly, the vector BC is giving us a displacement from the point B to C. So if we ask you that what is the net displacement, that is of course from A to C, which will be given by the vector AC, and we see that this ABC of course forms a triangle. So now we can say that if we go along AB and BC, the sum of this is equal to if we would have gone along A to C. So this is nothing but the triangle law of vector addition, and so what it tells that AB plus BC is equal to AC. That means the third side is giving the sum of the other two sides when these sides are represented as vectors. But mind it one thing, that if we think of a triangle property, do you remember any triangle property which is similar to this or otherwise? In fact, I hope everybody remembers that we have a very important property in triangles, that sum of any two sides is always greater than the third side, but which is contrary to the result what we have obtained here. That means that result is true when we are considering only the lengths, that means the scalars. But when we are thinking in the perspective of vectors, we have the result like this, that sum of the two sides is equal to the third side. Okay, and now if we have already taken two sides of a triangle. Now if we have two arbitrary vectors A and B, how will you add them? Of course, you have to shift B and put it like this, so that the terminal point of A coincides with the initial point of B, and we can construct a triangle with this A and B as two sides. And now of course, as already discussed, our triangle law will give that the third side AC is equal to AB plus BC. Also note another interesting thing from here. If we go along the sides of the triangle AB plus BC plus CA, of course that is equal to AA. Starting at A, we have reached at A, so the net displacement is 0. So this is a null vector, and I think you remember that null vector is a vector whose initial and terminal points coincide. Now we will now utilize this triangle law of vector addition for finding the difference of two vectors, or rather we will use this triangle law to subtract one vector from another. So how we can do this? Let us see in terms of this figure. So suppose again AB are two vectors which are forming the two sides AB and BC of the triangle ABC. Now by triangle law we already know that this AC will be A plus B. Now how we can subtract also? So we construct BC dash as minus B. We know that negative vectors are nothing but opposite vectors. And now if we apply the triangle law to this triangle ABC, what do we get? AB plus BC dash, that means A minus B, that is equal to AC dash. So now the difference of the two vectors is given by this side AC dash. Next we go to the another law which we have already told, that is the parallelogram law. So what is this? Now actually there may be situations that where we have co-initial vectors, that means vectors starting from the same point. In that case we cannot apply the triangle law, because the triangle law needs that the starting point of the second vector should be same as the terminal point of the first vector. So if we have co-initial vectors, we cannot apply the parallelogram. We cannot apply the triangle law. So now for that we need this parallelogram law. So what we do is we draw a parallelogram taking this A and B as the two sides of the parallelogram, two adjacent sides. So now suppose we have the parallelogram OACB. Now it's very obvious that OB is parallel to AC, and therefore AC will be also equal to the B vector. So now if we apply the triangle law to this triangle OEC, then OC, which is actually the diagonal of our parallelogram, that will give A plus B, because OA plus AC, that is going to be your OC. And so now if we see that AC is equal to OB, so therefore we can also say that OA plus OB is equal to OC. That means sum of the two sides OA and OB, that is nothing but the diagonal of this parallelogram. So this is your parallelogram law of addition of vectors. That means if we have two co-initial vectors, we just draw a parallelogram with this adjacent sides, then the diagonal gives the sum of the two vectors. And now the next thing is, here in both the laws we had been talking about how to add two vectors. But if we have more than two, how will you do it? Say in this figure we have a number of vectors, A vector given by AB, small b vector given by BC, similarly C, D, E, F, G. So what will be the sum of A plus B plus C up to G? Now here we will use the same concept of displacement, that via this A, B, C, D, E, starting at the point capital A, we are actually reaching at the point H. So what is the net displacement? That is the vector small h or AH. So therefore the sum of these vectors is nothing but this H vector. So this H vector is now called the sum, and this A, B, C, D, E, F, G, H is called the vector polygon. Now after having this, having seen this different types of vector addition, now we look into the properties of vector addition. The first one is a very important and interesting property, that for any two vectors A and B, A plus B is equal to B plus A. That means the order is not important. We can play around with the vectors in any order. And why is it so? That we can understand from this figure. So we have two vectors A and B, which form the two sides AB and AD of the parallelogram ABCD. Now see, if we have considered the triangle ABC, then AB plus BC is equal to this third side AC. So this third side AC represents A plus B. However, if we have considered the triangle ADC, then you see AD plus DC, that means B plus A, that is the third side. So therefore AC, the diagonal of the parallelogram, is representing both A plus B and B plus A, and hence they are equal. So the next law is the associative law. Now we have three vectors A, B, C, and we see that A plus B plus C is equal to A plus B plus C. So that means we can actually again play around with the brackets. It does not matter which pair we add first. If we add A and B first and then to the sum we add C, that is same as if you add B and C and to the sum we add this A. So why this is so? Again, we can understand this from this figure. See that we have three vectors in both the figures 1 and 2, A, B, C, where A is represented by the vector PQ, B is QR, and C is RS. Now, if we add A plus B first, as in this figure 1, then we will consider the triangle PQR and then this third side PR represents A plus B. Now, with this A plus B vector represented by PR, we add the C vector. So, again by the triangle law, the third side PS represents A plus B plus C. In the second figure, we are first adding B and C. So, adding B and C, we get this third side of the triangle QRS, which is QS. So, B plus C is now represented by QS. And now if we apply the triangle law to this PQS, we will see that it is given by the third side PS. So, therefore, both cases we get PS, and this shows that A plus B plus C is equal to A plus B plus C. And we get go over to the third law, the last, not last, but the third one. This is the additive identity. So, see that if we add the null vector 0 vector to any vector A, we will get the same vector A. Why? We remember that 0 vector means its length is 0. So, the length of A does not change, and 0 vector or null vector has arbitrary direction. So, it gets the direction of the vector A. So, A plus 0 is A, and by your commutative law, A plus 0 is equal to 0 plus A. So, this is the law for additive identity, or rather this is called the additive identity for vector addition. And next we have the last one, the additive inverse. So, again, any vector A plus minus A will be the null vector. Why? A, suppose it represents the displacement from A to B, the AB vector. So, if we go back, we will come from B to A again. So, ultimately the starting point and the terminal point will be same. So, it will give the 0 vector, and this minus A is called the additive inverse of A. So, with this we reach to the end of this lecture on vector addition. In the next class, we will continue with the other algebraic operations. So, the next one to come after addition and subtraction also actually we have discussed today. So, the next one is going to be multiplication. Okay, thank you and goodbye till then.